So as a math teacher, I gotta like try to judge. You know, when I saw this slide, I didn't make this slide. Some other teacher did, and I'm like, what? I wonder what they were thinking of. I immediately looked at the right end. Would everybody circle the right end of each one? Just to get you actually moving, doing something like, for instance, right there. That's the right end of the graph 1. I'll circle the right end of graph 2. I hope you circled right there. The right end of graph 3. Right end of graph 4. See what I'm doing there? So, which one didn't belong? Come on, say it. It's pretty obvious. Number 3. Number 3 was different. Why? Because it had a right end that was on. It was down. And what does that mean about its graph? That means if you were to look at its graph, it would have had to have a what in front? Say it. Come on. A little participation would be good. A negative in front. Yeah. So its graph had to have a negative in front of whatever it was, like x to the third plus 2x squared plus x minus 2. Whatever this graph was, there had to be a negative there. That's called the end behavior. All right. How about the left end? Let's look at all the left ends. This one was down. This one was up. This one was up. This one was down. So you can't really do it by left ends. But this one here that I just drew it out, could this possibly be the right answer? Well, it's got a 3 here. That's called the degree. And it tells me that it's an odd number. If it's an odd number, is this the right graph for it? Yeah, they go different. Remember how odd means different? Okay. All right, so let me give you one. You come across this graph. It says negative 4x to the 5th plus 3x squared plus x minus 8. I'm going to ask you to tell me a bunch of little things. Everybody write out 1, 2, 3, 4. You don't have to write the equation. You just have to write 1, 2, 3, 4. I'm going to ask you 4 questions. See if you know these 4 things. What's the lead term? You don't have to write lead term. You just have to write the answer to lead term. Bennett, could you drop that in your backpack, please? Phones were fine during the news show, but you got to put the phones away. I know you're not using it, but just put it away. Thank you. All right. So lead term. Number 2. What is the lead coefficient? I'm just going to abbreviate it lead co. What's the lead term? What's the lead coefficient? What degree is it? And what's it doing on the left and what's it doing on the right? I always start with the right side because it's easy. If there's a negative in front, boom, you know the right side. The left side is a little more complicated because you got to look at the power, and if it's odd, you do one thing, and if it's even, you do something else. All right, so let me go through these answers with, I'm going to talk to the kids at home. John Piper, can you tell me any of these, 1, 2, 3, or 4?
Degree 5.
It is degree 5. You are correct, sir. Let's go to Bertha. Can you tell me? Oh, sorry, you're in the room, but that's okay. Can you tell me the lead term? Negative 4x to the 5th. The whole thing is the term. Very good. Next up, Angelina Fisher. Can you tell me the lead coefficient?
Negative 4.
Yep. And last but not least, Luke Scrivseth. That negative tells you the left or the right?
Is it going to tell us the left?
Nope. This thing in the front tells you the right end. Now tell me this. Does it feel like that's telling me the right end is going to be up or down?
Down.
It's down. The right end is down. Okay, so what's in front, that tells you the right end. Nathan Vikram, how do you figure out the other end?
From the exponent.
You are correct, Vikram. This exponent right here is 5. What does that tell you?
That it's different from the right.
It's got to be different. If you wrote the word different, I'd mark it wrong. So what should we write?
Up.
Yep, right in there, we write up. Okay, cool. Now that's a lot of stuff. What's different for today? What's different for today is the same exact kind of problem can be written like this, where it's all factored out. Now how are you supposed to know what the lead term is? Now how are you supposed to know what the lead coefficient is? Now how are you supposed to know what degree it is? Now how are you supposed, you know what's really easy? You just multiply it out. And then you'll know all the same things we knew before. You know what I mean? Once I get this multiplied out, it'll be exactly like the other problem we just did. So everybody just take a second and multiply this out. That times that. Javon, you're in charge of that one. That times that. Bertha, you're going to be in charge of that one, the blue one. Javon, you got the black one. The green one, that's going to be, you're in charge of the green one. Okay, and you are in charge of the yellow one. Javon, what do you think it is when you have an x squared times an x? I think you're subtracting them. You're multiplying them, and so when you multiply them, you go x squared times an x, x to the third. It's all right. That was the hardest one. How about the blue one? Who had the blue one? Bertha, what do you get? Yep. X squared times negative 5 makes negative 5x squared. She just did this one times that one. All right. And who had the green one? Please? It is 3x. And then last but not least, negative 15. There it is. Now it's easy to tell what the lead coefficient, the lead term. Dylan, there's no number in the front. So what number is really in the front? Right here. You are correct. That one has a special name, Dylan. Do you know it? Leading coefficient. Very good. Since that leading coefficient is positive, Dale and Thomas, what does it mean that the leading coefficient is positive? Positive goes up. You are correct. So it goes up on the right-hand side. We always do the right-hand side first. Now, Jack, the left end. Down on the left end, because why? Odd number for the, what's that called? Starts with a D. The degree is odd, so it goes down on the left. Okay, cool. Now, one more thing that we can do that's pretty powerful is if we have one that's factored like this, a nice and simple one, then we can say, oh, I know that it touches at, here, let me make it a little different. Let's make this a minus so you can see the difference between the two. I know it touches at x equals negative 5 and x equals positive 4. Those are called the zeros. So those are my two x-intercepts. One's at negative 5, hits right there, and one's at 4. Hits right there. So I know a little more info. It not only, I know it's going to go up on the right. How do I know it's going up on the right? Because I already in my head, real quick, multiplied this out. X squared was the lead term. That's a 1x squared. That means it's positive. That means it's up on the right. And since it's squared, I know it's the same on the other end. I know it's up, and I know it's up. Do you get, then I can just kind of complete the puzzle? It has to go like this. That makes sense? Has to go through those two spots. Those are called the zeros. Has to be up on the right, has to be up on the left, and I know what it looks like. All right, so another one. You get x minus 6, x plus 3. I know so much. First in my head, I quick multiply it out and go x squared. You know what? The rest of it doesn't really matter much. Could I multiply the rest out? Sure. But do you get that the lead coefficient is the main thing? Like, that's the big deal? I know it's x squared, so boom. I know it's going up on the right, up on the left. And then I know the two spots it hits. This one, -3. This one, +6. So here's +6. Here's -3. And it has to go through those two spots. Here we go. That's how it has to look. So if it's in factored form, you just multiply it out and poof, you've got standard form. Now let's do a little bit of review of some test questions. What? Was test like tomorrow? No. Test is not tomorrow. But it's going to be coming up next week. Okay? And I want to just try to get you ready now so that you'll be even more ready then. So here's the typical question. X to the third minus 6x to the fifth plus 4x minus 9. And they might say, what's the lead term? Be careful. Dylan, did you catch the trick? All right, so what does the lead term start with? There is a 1 there. You are correct. But is that really the lead term, Javon? No. You caught it. What's the lead term? 6x. Boom. -6x to the fifth plus x to the third plus 4x minus 9. You got to write them in standard form first. Then you can decide that the lead term is that. The lead coefficient is this. And the degree is that. You know what I mean? We just had to rearrange it. Why did we put that first? Because it's the most powerful one. It's to the fifth. It's like the general. It's like the 5-star general. The boss of the boss. In Minnetonka, that would be Dr. Peterson, the superintendent. He's like the #1 most important, like, powerful person. Technically, he would say, actually, Mr. Server, it's the school board. It is true, because the school board is like 5 members of the community that get voted in. They can fire him. So I guess that makes them the most important. The school board can fire the super, but the super can fire everybody else underneath him. So he's kind of the most important, but he has to answer to the board. Okay, anyway. Did you get how you just had to be careful because the second term might be actually the lead term? Because this should have been in front, but it wasn't. Okay. Let's do the rest of the slides. We already did our summary so far. Do you get that the left side, if you multiplied it out, would make the right side? This one's factored. This one's standard. Okay, so you just multiply them all out. That's my advice to you, is just keep your life simple. If there's a problem that's not multiplied out, just multiply it out. And then it's like what we were just doing a minute ago, and everybody was seeming to follow it. When they were like this, it's pretty easy. Lead term is at 6x squared. What's the lead term here? I don't know. I multiply it out, and then I can see lead terms here. Sorry, I feel completely well. Just joking on something. All right, so anyway, find the leading term from factored form. Well, this is just saying we know this end is up and up. This one's down and down. You know, just looking at the pictures. This one's down and up, and this one's up and down. And this is just reminding you how to multiply these puppies out. And we've already done FOIL so many times that I'm not spending much time on it. I hope you know how to do this. But I should really take a second and check. So I'm going to give you this. Would you please just multiply this out? And I'm going to see if you can do it. You don't have to use FOIL. It's just distributing. like this, the blue one, and the black one, and the green one, and the yellow one. Put them all together. Now this time I'm going to start practicing something where you're going to be comparing with the kid next to you. Okay, so I got to pair you with somebody today. Now sometimes it's going to be groups of 3. Sometimes there's a logical, natural person who just sits right next to you. Okay, and all you got to do is, like, you know, show them what you got and see if you got the same thing. And if you didn't, take a second and, like, the person who's like pretty sure that they're right, like, what if there's 2 answers, right? If you're like pretty sure you're right, like, say, oh no, I think you got to do it this way. So explain it to them if you don't have the same thing. So everybody, we're just multiplying this out now for today. I'm going to pair U3, 1, 2, 3. Okay, so you guys are going to compare in a little triangle of 3 people. You two are going to compare with each other. You guys, we're going to do a little triangle of 3. 1, 2, 3. You're all going to compare your answers with each other. You two are just going to compare straight across. You two compare straight across. I think we're going to do forward and backwards. You guys, and then you guys. Okay? And you, I guess I'll put it in a group of 3 because otherwise you'll be completely alone. So, no, actually, let's do it this way. You two compare, and then you 3 compare with each other. Okay? You see a cell phone out on the desk. It needs to go away, please. All right, so we're going to FOIL this thing out. Just give us a hint. Bertha, tell us the first term. 2x to the 9th. Everybody make sure you started with that. You know why? Because x to the 8th and 2x. This 2x has a 1 on it. That's why it's 2x to the 9th. Now see what you think the answer is after that. Starts with 2x to the 9th, and it's got a lot more. Okay, take a second, finish it out. And I get there might be times when you're like, I just don't know. Just show as much as you know. You know what I mean? Like, I think the next term is this, and then I got stuck. And you got to be nice to each other because we're all in this together. You've seen me make mistakes, plenty. And, you know, this just, I want this to be a place where you can trust each other and just like, yeah, I'm not getting this, or I need some help. Can you show me what to do? All right. So 2x to the 9th is the first term. Compare now with the kid next to you. See if you get the same thing. And if you don't, talk about it a little bit. Don't be shy. All right, now I know there's kids at home. So who are you paired with? You're paired with everybody that's in the virtual room. So when we do this, I'm going to open up another room called the hall. And you guys know that the hall exists. You've been, well, many of you have been there before. So in the virtual room called the hall, next time we do this, you guys, I'm going to have you guys jump in that one. And you guys will be talking to the other kids that are in the hall. But right now, just stay where you are because that was quick and everybody's already done. But I'll have you guys that are online jump into the hall where you can talk to each other and get each other's opinions on this. All right, so let's get back to it. Did you compare with somebody else? And did you guys have the same answer?
Well, I didn't have it all, but they did.
Okay, all right. One of you two then. How about you? Would you tell us what you got? So 2x to the 9th was a good start, and then what? All right. Put your virtual or real hand up if you had the same thing. Okay. All right. Now, if you didn't know how to do that, take a look at it for a second and try to figure out where you went wrong. Okay, because we got to all know how to multiply these out. All right, now that I got it multiplied out, the cool part is that's a lead term. Yes. Okay. Somehow my iPad stopped presenting. Oh, no, I just switched it to the, okay. If we're in the room, there we go. Now we can see it better. Okay, so this one's the lead term. This one's the lead coefficient. This one's the degree. And this one, would it be up on the right? Raise your hand if you think it's up on the right. You are correct. And would it be up on the left? No, why not? Because the power is odd. An odd power means you have to be different than the other side. So the right side was up, the left side would have to be different than that. Okay, moving on. So, what if it's got three things? Holy crap, we have to multiply those out? You don't have to multiply it all the way out. There's a shortcut way. Watch me do it. All I gotta do is this times that. Well, what's this times this? 2x what? Squared. And then if I times it by another x, 2x to the third. That's your lead term then. Do you remember me saying before, I don't really care about the rest of it? It's all about the lead term. There you go. Now I know it's degree. Boom, it's degree 3. I know that its lead coefficient is a 2, and since that's positive, it must be up on the right. And since it's the odd, it must be down on the left. So look how I just had to grab the first ones and multiply them all together. Let's see if you can do that. They threw in a negative here just to be sneaky. And that does count. Multiply these 3 together and see what you think you get. I'm going to go with Martina. What do you think those 3 multiplied together make? Yes, perfect. 2 times 3 makes 6. Why is it negative? Because of that negative on the x. Then the x to the third, x to the 1, and x to the 1 makes x to the 5th. Perfect. Now, it's negative. Right side's down. Got it. If a negative book has a sad ending, right? It goes down at the end. Negatives. All right, and then is it the same or different? Oh, it's odd, so it must be odd degree. So it must go different on the other end. All right, I hope you feel like this isn't that hard, because it's that hard. It looks really scary. But this is probably harder than anything we would test you on. But this is really an x to the third. This is really an x to the 8th. Do you see what I did there? This is an x and this is an x. So x to the third times x to the 8th times x times x. Put it all together. X to the 8, 9, 10, 11, 12, 13, x to the 13. That's pretty rough. And I think that might be beyond what we would test you on, but it's not like it's impossible. It's just getting from here to here and here to here. That was the only thing that was really scary. The rest of it's just adding up exponents. Okay. All right. So take a look at this one. Just make sure it's in standard form, meaning that there isn't some number that's out of order. And then, could you please tell me the degree, the lead term? I'm going to do 1, 2, 3, 4 again. Lead coefficient, and the left end and the right end. Always do the right end first. This one first. Everybody try this. 4 questions. What's the degree? What's the lead? What's the lead co? What's the left? What's the right? But always do the right first. Angelina Fisher, which of those do you think you can do?
Would the lead term be 6x squared?
Nope, because this is more powerful than an x squared. I think you're overthinking it.
Yeah, okay, so the lead term would be 5x to the 4th.
All right, excellent. And Luke Scrivseth, what's the degree? Yep. And Dallin Thomas, what's the lead coefficient?
4.
And does that tell me the right or the left side?
The left side.
Nope. It's been twice this hour. Everybody messes that one up. This thing tells me the right side. I know we usually go from left to right, but it tells you the right side. And since it's positive, Alban, the fact that the 5 is positive tells me the right side is... You can't really say that the right side's positive. I mean up or down? Up. And then the left side, Javon, looking at this 4, are you feeling like the left side's going to be the same or different? Why different? Even goes with same. And odd goes with different. Think about that. If I said that's odd, wouldn't it be saying like that's kind of different? Okay, it's odd and different. It's even, same. This one's even, so it's the same. So it's the same as up, so you are correct. You said up, you were right. It's up. Okay. Don't feel ready for the test yet? It's okay, because it's not tomorrow, and it's not Monday. It could possibly be Tuesday, but at least we'll have plenty of time to review between now and then. All right, so we have a worksheet, U10 L3. Let's everybody go take a look at that right now. And I haven't actually taken attendance yet, so I got to still do that. But I wanted to get you to the homework as fast as I could, and there was a lot there. I did review some, because I think that's the secret to good grades, is a teacher reviews a lot, because it really makes it stick. Now, the worksheets usually are a little bit large, in my opinion. The key is doing something at home, not doing a lot. But if you don't think about math between now and tomorrow, it won't stick. There's a critical 24-hour forgetting window. And so I do want you to do some, but I don't need you to do the whole worksheet. So here's what I want you to do. On U10 L3, it's this one right here, and it's one linked in today's, you'll see it in today's folder. Today's date is the 15th, so it's 4/15. I am going to have you, we'll skip the middle two. No, wait, I'm wrong. We will skip 4 and 5. We may skip problem 4 and 5. So let's get started with number 1. Number 1 looks like this. F of x, which is the same thing as y, is 4x plus 1 and 2x minus 1. Dang it, I have to multiply it out. But that's the whole point of today. You can do this. Jack, can you tell me what the 4x and the 2x make when I multiply it out? 8x squared. Nice. Now the 4x and the negative 1, Jack. Very nice. Bertha, now the 1 and the 2x. Plus 2x. And now Bertha, the 1 and the negative 1. Nice. Now, is that in standard form? No. Angelina Fisher, what needs to be put together to make it standard form?
The negative 4x and the 2x.
Very nice. And they make what?
2x.
Yep. Positive or negative?
Positive.
Nope, because the negative 4 was bigger, it's negative 2x. Easy mistake to make, though. There, I multiplied it all out. Now, remember me saying I really didn't even have to multiply it all the way out to figure out the leading term, the degree, the lead coefficient, and the end behavior. What was it all based on? This. Does it even say to multiply it all out? No. So I actually made you do extra work on that one. You could have just figured out this first one. If you got the 8x squared, you got everything. All right. So Dylan, Nault, what is the leading term? We're answering the 4 questions. Yep. Lily Studensky, what is the degree?
Would it be 2?
It is degree 2. Where'd you get that from?
The exponent?
Yep, the exponent on that leading term. Very nice. And still, Lily, leading coefficient.
Would it be 8x to the 7th power?
No, that's the lead term. The leading coefficient,
Oh, it's
8. And last but not least, the end behavior. There's a right and a left. Jack, which side should I start with? Very good. Right going up. How did you know it was going up? Because this is positive, and that's like reading a story and you know it's a positive book, so it's got a happy ending and it's going up. And then last but not least, should it go the other way or should it be the same? Matilda.
It should be the same.
All right, because why?
Because
All right. They're both going to be up. This one's even, and that's a hint that even means the same. They're both going to be going up. All right, there's our first answer. You may skip problems 4 and 5. I feel like you're going to finish this pretty quick, but there might be one that stumps you. Remember, that's what I'm here for. You just got to say, hey, Mr. Server, can you help me with the beginning part of number 3? I'm stuck on that. But let's talk about number 3 for just a second because it does get a little weird. I know what somebody's going to do. Somebody's not going to notice the little squared. So everybody, notice the little squared. Why does it matter? Because somebody's just going to say it's 6x times x, which makes 6x squared. It is not 6x squared. Got to count that. If it's not 6x squared, what is it? Six x to the third. This one's a 1, and this one's really a 2. And you add this kind. So 1 plus 2, 6x to the third. Appreciate the effort. Really do. All right. And that's the lead term. The lead coefficients on the front of it, the degrees on it. The fact that it's positive tells you one of the ends is up. Hopefully you know they always start with the right end. And the left end should be odd. It tells me different. So these ends have to go different ways. All right, but I think that squared right there would have caught a lot of you if I hadn't called it out. So watch out for that. There's another one of those on problem 6. All right, I hope you feel smarter than when we started. Tomorrow I have a real treat for you. Every year I try to buy something that makes my class a little more interesting and better. And this one year I bought a true mirror. I want you to think about what a true mirror might do. Okay, you guys know about a mirror. You've all looked in a mirror before. I would bet none of you have looked in a true mirror. Do you have any clue what I'm talking about? Yes?
Is it instead of reflecting yourself, it's like a real you?
So yes, it has to do with the reflection of yourself. Obviously, I don't know if you even have processed this, but when you look in the mirror, that's not how you really look. Have you ever even thought about that? Your face is reversed of that. Because, like, I'll prove it. If you look at a word, like, let's say you wear a sweatshirt that says, you know, NDSU on it, is backwards in the mirror because your face is reversed. So let's say that your smile tends to go up on the right side of your face. You've always seen it in the mirror is out going on the left side of your face. That's not how other people see you. Other people see you reversed from what you see yourself. So if you've been looking in the mirror to see what you kind of look like, if you really looked at yourself in this true mirror, at first you're not going to like it because it's backwards from what you're used to, but that's what other people see when they look at you. So I'm bringing in my true mirror. It works by doing a reflection of the reflection, and it gets you back to how you actually look. So I think someday, I think everybody's mirrors will be true mirrors, because I think mirrors will go away and it'll be a panel that'll use a camera. So your mirror will be actually a camera looking at the room, and they can keep that normal. But people are so used to looking in mirrors that your iPhone actually, when you look at yourself in the iPhone, it actually switches you, it mirrors it, because people don't like how they look because they think they look wrong. But because people are looking at the mirror so long that they think they look a certain way, but they really don't. So anyways, I think it'll be kind of fun. That's happening tomorrow. That's all I got for the video for today. This worksheet again was U10 L3.